Alrighty, Math 10C, we are on to chapter 2.2, using the tan ratio. So the best part about right angled triangles, okay, this is all up top here, is that all you need is one angle and a side length to figure everything else out about the triangle. So right triangles, remember, we all know this, has a 90-degree angle. This would be the hypotenuse because it's the opposite side to the 90 degrees. And then you got a leg here, and then you got a leg here, okay? The best part about all of this is if you have an angle other than the 90 degrees, okay, so the 90-degree angle doesn't count. If you have, like, say, this angle here, and you have the hypotenuse, you can solve for everything. You could solve for this leg, and this angle. So all you need is an angle other than the 90-degree angle and one leg or hypotenuse length, okay? Now, in order to be able to do all this, we must practice and learn how to manipulate the tan equation to solve for either opposite or hypotenuse, okay? So that means we got to practice manipulating formulas. So you can see this formula here. Tan angle equals opposite over adjacent, okay? Now, this is really important to understand. You can technically do cross multiplication and division. I am not going to do cross multiplication and division in this unit at all, okay? Because once we start getting into chapters 3, 4, 5, 6, and 7, you need to be really good at manipulating formulas. Cross multiplication only works as soon as you have ratios that look like this. Really simple ratios. As soon as we add something to it, there is no longer the ability to do cross multiplication here. Okay, so let's erase this. Okay, let's get it out of our way. So how do I manipulate? Okay, so I'm gonna solve for opposite on this side. Okay, so we have our ratio. We have tan angle equals opposite over adjacent. Now say I want to solve for opposite. Say I have the angle and I have adjacent and I need to solve for the opposite. How do you do that? Well, remember, we want to do the opposite operation to get, so realistically, we want to get adjacent to this side. Okay? The way we get adjacent to this side is by canceling out the adjacent on this side. How do I cancel out? So when it's multiplying something or dividing something, you need to do the opposite operation. If you look here, what we could do is multiply both sides by adjacent over 1. Okay, you don't technically have to put number 1 on the bottom here, but it'll make more sense why we do that once we start solving for adjacent, okay? But anyways, we're going to multiply both sides by adjacent. And remember, what you do to one side, you got to do to the other. So in this case, what are we going to do? Why did we do that? We did that because now you have this adjacent dividing this adjacent, okay? And that's super important because adjacent divided by adjacent cancels out. And then on this side, you get adjacent multiplying tan. And then again, you're dividing 1, but remember, anytime you divide by 1, it just stays the same. So you can write this other side now as adjacent multiplied by tan angle equals the opposite leg. So there's us solving for the opposite side. Okay, so you need to know how to show and do that. Let's solve for the adjacent side. So solve for adjacent. In Math 10C, your cross multiplication is not going to get you very far. I can tell you that much right now. So although this might seem like it's going to take longer, it's going to help you in the end, essentially. Especially if you're going to be taking the -2 or -1 stream, you're going to want to know how to do this. Okay, so remember, we wanted to cancel out the adjacent. It was dividing things, so we multiplied both sides by adjacent over 1. This time, we're actually solving for, we're actually going to solve for adjacent, okay? We want to know what this value is, so we have to get it alone, Okay, how can we do that? Well, the way we can do that is we want to, if you ever are solving for something on the bottom, we want to get it to the top. Okay, so we're going to do kind of the same thing here. I'm going to multiply both sides by adjacent over 1 because I'm trying to get it. I should have gave myself more room here. I'm trying to get it to the top. Okay, so that's adjacent over 1. So what you do to one side, you got to do to the other. Okay, and now at this point, our adjacents cancel out. Now we have adjacent multiplying tan angle, and that equals the opposite leg. But remember, we're trying to solve for this guy. So we got to do the opposite. Now we need to get tan. We want to get tan angle over here. How do we do that? Well, it's on the top and it's multiplying everything. So I'm going to divide it out. What you do to one side, you do to the other. Okay. So we can see here now that adjacent equals opposite over tan angle. So there's two algebraic methods, okay, to solve for both sides. So you need to know how to do this, okay? Cross multiplication will only get you so far, okay? If you want to go into the -1 or -2 stream, you got to learn how to manipulate formulas. Okay, so let's look at example 1 here. So consider the triangle PRX. If PR has a length of 30 centimeters and angle X has an angle of 25 degrees and angle R is 90 degrees, determine the side length of X. So as soon as you see this, we know that this is a right triangle. So let's draw a right triangle and then we can show what this looks like, okay? So R has to be 90 degrees. So I'm going to make this R because it has to be 90 degrees. And then here we could just make this P and then this X, okay? Remember, it told us that angle X is 25 degrees. So here I'm going to put 25 degrees. It told us the length of one of these sides. PR has a length of 30 centimeters. Thus, PR, which is this length here, I can then plug in 30 centimeters. Okay. It wants us to find the length of RX. So this is our question mark. Okay. Remember, I could either represent this as small p because it's across from our vertex P, or I personally like my notations as R to X. Okay, so Rx is our question mark. Now, with trigonometry, you need to be aware and remember that you are going to end up having 3 different really important ratios. So, ka, toa. Okay, you have to know which ones to use. You always want to ask yourself, okay, what am I given? Okay, and which ratio relates the given values to the unknown values? Okay, so if we look here, we're given 25-degree angle. Now remember, you always want to first show where the hypotenuse is. It's across from the 90-degree. So there's my hypotenuse. Okay, so I've now shown which one's my hypotenuse, which is pretty much you always want to do that. Make sure you clarify where your hypotenuse is found. Okay, it's across from the 90-degree angle. And look at what ratio here, sine, cos, or tan, relates this angle to these side lengths. Well, if we see, looking at the perspective of angle 25, we can see that we have the opposite length, and we're trying to find the adjacent, okay? remember that hypotenuse can never be adjacent. So here is our opposite of 25, and this guy would have to be our adjacent because hypotenuse cannot be adjacent. So opposite and adjacent, that's toa, okay? Opposite and adjacent, okay? Opposite and adjacent. So we clearly need to use tan here. So let's write our tan equation. Tan angle equals opposite over adjacent, okay? Now at this point, we can start solving for some things, okay? So our opposite side length is 30 centimeters. So I'm gonna write this generic, okay? So tan, and I'm gonna put 25 degrees in here, okay? So tan 25, what's the opposite side to 25 degrees? Well, it's the 30 centimeters, right? It's opposite of that. So it would be P to R. So I'm gonna write PR. Then we're looking here, what's the adjacent side? The adjacent side is R to X, okay? So that would be R to X, which is what we're trying to solve for here. Okay, so let's plug in the values that we know. Again, we already know what tan 25. PR is 30 centimeters. And then Rx is what we're solving for. And now we have to know how to manipulate this formula, but we already know how to do that, okay? So we're solving for R and X. Remember, Rx is on the bottom. We need to get it on the top in order to solve for it. So the first thing I'm gonna do is multiply both sides by Rx over 1, okay? I'm gonna move this over a little bit. Okay, and I'm gonna multiply this side by Rx over 1, okay? Remember, I'm multiplying it Rx over 1 because I need to know that Rx divides out on both sides. I'm going to rewrite this equation to make a little bit more sense. So this is simply Rx times tan 25, and that equals 30 centimeters. Now I can solve for Rx because tan is multiplying Rx. To get tan to the other side, I need to divide. So now I'm solving. So divide tan 25. Okay, and that cancels out my tan. And we get Rx equaling 30 centimeters divide tan 25. So how do we plug that in our calculator? Well, let's pull out our calculator. Okay, if we pull out our calculator here, I'll clear everything. I'm going to press 30. Okay, so delete 30 dividing. So I would honestly suggest practicing plugging this into your own calculator alongside with me. Now we need to press tan. So I'm going to press my tan button. And I actually have my degree, so I don't need to use inverse tan because we're plugging the degree into tan. So tan 25 equals, and now we are getting 64. And does it tell us to round to anything? It doesn't tell us to round, so we're going to round to the nearest tenth. So the 10th, if we're going to round it to the 10th, let's just write this all out so we can practice. The 10th would be this, 1 decimal place. So that will be 64.3 centimeters. Okay, and there's our Rx length. Now, some things to note. If you think you plugged this in properly into your calculator and got a totally different answer, you might be in the wrong mode. So if you can see here in this row, the second button, okay, the second button, which is mode there, you can press that and it will open up a new screen. Okay, and then what you want to look for is your angle. So you can either be in, I'm going to switch it, degree or radian. You want to be in the degree mode, okay? So make sure you know how to get to the degree mode because if you're in radian mode, you're going to get the wrong answer. Okay, so you need to be in degree mode. So yeah, if you're having troubles getting that solution, make sure you either rewatch this video, take the notes down, and then come ask questions, okay? Other than that, that's how you solve for that one. So we manipulated our formula nicely and then solved for our x, which is awesome. Cool? Now, let's go on to example 2. So example 2 here, we want to determine the value of h, okay? So remember, right now we only know one ratio, but as we move forward, we are going to know 3 ratios. So you need to know which ones to use and when. Here, I'm going to assume that this is 90-degree angle, okay? We don't normally get to assume. This should have said this triangle is 90-degree angles, but it looks pretty 90-degree, okay? Now, at this point, we're given an angle and we're given a length. Just like we talked about, if you have an angle and a length, that means you can solve for pretty much anything in this graph, or sorry, in this triangle. So ask yourself, what relates the angle we're given to the length we're given and the thing we're trying to find? Remember, we will have 3 options, but in this case, find your hypotenuse always. So our hypotenuse is across from the 90-degree. So we've labeled our hypotenuse because remember, a hypotenuse can never be adjacent. We're trying to find the opposite side length of our 18 degrees, and we're given the adjacent. Remember, this won't be adjacent because it is the hypotenuse, okay? So what relates a degree to its opposite length and adjacent? That would be TOA. Tan equals opposite over adjacent. So we're going to have to use tan angle equals opposite over adjacent. And then here, we are known a few things. So if we plug in tan 18, what's the opposite length to 18? Well, if we look across from 18, we can see that it's h. So I'm going to represent opposite as h here. And what's our adjacent? Remember, even though hypotenuse is technically beside, it cannot be adjacent. So our adjacent has to be 100 meters. So over 100. And now we can solve for h here. Okay. How do I solve for h? Well, h is already on the top, which makes this a little bit nicer to deal with. And what I'm going to do is I need to cancel out this 100 meters. Okay. In order to cancel out that 100 meters, I'm going to multiply 100 meters over 1 by both sides. Okay, and remember 100 over 1 is simply just 100, but it's good to represent it as a fraction because it's a little easier to see that you are going to cancel these guys out. And then you're left with 100 meters multiplied tan 18. Something to note is you could put this all over 1 because of this guy. But realistically, that's going to equal the same thing. Any number divided by 1 is always your same value there. Okay, so let's plug this into our equation, into our calculator. So 100 multiplied by tan, so I'm putting the degree inside. I don't have to do inverse because I'm not finding the degree. And remember, I'm in degrees mode, and that gives me 32.49. I'm going to round this to the thousandth, okay, or 3 significant digits. So 32.4919, and I'm going to round it to the thousandth with this 3 decimal places. So that's 32.492. I have to round up this 1, okay, have to round that 1 up because the number beside it is a 9 to the right of it. So what's the measurement here? It would be in meters. So 32.492 meters. And there is my height. Okay. So make sure you practice plugging in that into your calculator because a little bit of calculator work can be difficult sometimes. So we got one more question to do. It's a multi-part question, and it's all about word problems. So word problems, you need to get into the habit, and this is not even just for word problems, but especially word problems, always try and draw a diagram. If you can visualize it, your brain can understand it better. Always list what you have. Even if it says in the question, list it, okay? List it somewhere in your own kind of words. Because if you don't list it, you're gonna have to keep referencing the question and reading, which will just tire you out. Always list what you need. So if you need something, obviously it's a question, so you know you're gonna need something. List that down, okay? As soon as you list down what you need, okay, you might need to find more things to find that. So always list down what you need and then break each sentence down. So maybe read over the question once, get a general understanding, and then start breaking things down based on each sentence. That's how I work through it, and it'll help you organize your work. So let's read it through first once. A ship's sonar locates a treasure chest at 12-degree angle of depression. A diver is lowered 40 meters to the ocean floor. How far to the nearest meter does the diver need to swim along the ocean floor to get to the treasure chest? So that's a lot of information. Let's first draw what's going on. So you have a ship's sonar locates a treasure chest at 12-degree angle of depression. A diver is lowered 40 meters to the floor. So we have a ship. Okay, so I'll draw a really poorly drawn ship. Okay, and it's floating on water, obviously. Okay, and what they're doing is we can see that we are 40 meters above the ocean floor. So if we draw the ocean floor here, there's our ocean floor. Okay, and now we have a height. So we are 40 meters above the ocean floor. Okay, now this sentence here, a ship's sonar locates a treasure chest at a 12-degree angle of depression. Okay, well, you have a treasure chest. Okay, that would be really hard to see. Let's use this color. Okay, you have a treasure chest here. I don't really know how to draw a treasure chest, whatever, that looks pretty good. Okay, you have a treasure chest at a 12-degree angle from the ship. So if we draw that out, okay, so it's roughly there. Now, you're at a 12-degree angle of depression. Okay, so what the heck does that mean? That means this, remember, an angle of depression creates from the horizontal, okay, and downwards you have 12 degrees. So you have a 12-degree angle of depression, okay? The question is asking you, how far to the nearest meter does the diver need to swim along the ocean floor? So you have your diver down here. We dropped him down, okay? And they want to know what the length is here. Okay, so this is a pretty tough question. There's lots going on here, but now with this diagram, we can kind of start visualizing what's going on a little bit better. Okay, now at this point, lots of people would get confused. We have two triangles going on. You have this triangle, okay, but you also have this triangle, okay? And recognize they're actually the exact same triangle. I'm going to be using this triangle because I have my angle there. So recognize that this all the way down is 40 meters as well. This length that we're looking for also relates to how far this is. So now you can see we have two triangles, but we are given 12 degrees here. So I'm going to take this triangle out, I'm going to highlight it and draw it just in a very simple manner. Okay, obviously try and draw it nicely. Okay, I'll erase that a little bit. Okay, so we have, I'm going to represent this as S because that's where the ship is. This as T, that's where the treasure is. And then this can be anything. I'm just going to represent it as P. So now I have a triangle, and recognize this is a 90-degree angle because it's straight across and straight down. Okay, this is a horizontal, this is straight up, so that creates a 90-degree angle. This here is our 12 degrees. Okay, what else do we know? We know that the length upwards is 40 meters. We're trying to solve how far the swimmer has to go. Because remember, the swimmer is technically here. But remember, this length is the exact same as SP. Okay. So, like always, immediately determine what your hypotenuse is. It's right across from the 90-degree angle. So our hypotenuse is going to be here. Okay. Now, we're trying to solve for SP. This is us listing what we need to know. Okay, so when we've listed what we need to know, we've shown everything that we have. Now, how do we find SP? Well, think about how does the things we have relate to the thing we need? Well, if we can see here, we have an angle, we have the opposite side of that angle, and we're trying to solve for the adjacent. Remember, hypotenuse cannot be adjacent. So if we have the opposite and the adjacent, that should obviously make you think of TOA. Opposite, adjacent, so we're going to use tan. So tan angle equals opposite over adjacent. Okay. And now at this point, we can solve for SP. Let's plug everything in here. So tan 12, now we're thinking about it in terms of 12 degrees. So what's the opposite side to 12 degrees? Well, it's 40 meters. So here, I'm going to write this as PT, okay, because that's the opposite length to 12. And then the adjacent length is SP, which is what we're trying to solve for. Okay, and let's plug in our numbers and then solve. So PT is 40 meters. SP is our question, so SP. And now we can solve for how far this is. Okay, we just need to know a little bit of algebra. So at the moment, the thing we're solving for is on the bottom. Okay, so we need to get it up top. So I'm going to multiply both sides by SP over 1 to get it to the top. That cancels my SP out. And remember, when you're dividing 1, it doesn't really mean anything. I simply just do that for a visual. Okay, and then we get SP multiplying tan 12 equaling 40 meters. And then at this point, we can do some simple algebra. Tan 12 is multiplying SP, so I can divide tan 12 by both sides. Okay, and that's going to cancel this out, and we are going to get SP equaling 40 meters divided by tan 12. So remember, we're going to plug this in our calculator. I need you to practice plugging these into your calculator because sometimes that's the hardest part. So let's pull out our calculator and let's see how we plug this in. So we have 40 dividing, and remember, this is just regular tan because we're actually inputting our degree. Make sure you're in degree mode, okay? So as you can see here, I am in degree mode, okay? You can also press degree on your calculator, which is found in the same spot, and you'll be able to see and choose if you're in degree or radian mode. So SP here is 188.185 degrees. Now, did this question tell us what to give the answer in? It did. Awesome. It told us to do it to the nearest meter. Whenever it says the nearest meter or the nearest kilometer, that just simply means we don't want any decimals. So SP is going to equal 180. Well, let's check. This is going to stay 8 because the number to the right of it is less than 5. So that's 188 degrees. Okay. Or sorry, not degrees. Oh my goodness. We didn't solve degrees. That's a length. Okay. So we just solved the length. So that's 180. What are we measured in? Meters. So that's 188 meters. So this is 188 meters. So it looks like our diver needs to swim 188 meters to the right. Okay. Let's move on to B now. You can pause and copy this down if you need. Once the diver reaches the chest, what angle of elevation must he direct himself to swim towards the boat? So remember, if we draw this out now, we have our boat. Okay, we have our boat. We have our guy now at the chest. Okay, so our guy is at the chest. There's our really poorly drawn chest again. And we know a few things about this situation. This is 188 meters now from our last question. This is 40 meters. Okay. And now it wants us to figure out, since he's made it there, what is the angle of elevation he must direct himself to swim towards the boat? So he wants to aim himself directly towards the boat and get to it just by swimming straight at it. What is the angle of elevation? Remember, angle of elevation is made by the horizontal. So we have a horizontal and then we're elevating above from it. So this is our question. I'm going to represent this as angle for now, and this is our question mark. Now remember, we can figure that out because we have two triangles that we can deal with. Right now, we only have one triangle, okay? But remember, this side, 40 meters, also is 40 meters here. So if we draw that, this can be 40 meters. And also recall that the length here is also 188 meters. Okay, so now we have a triangle that we're going to use. Again, I'm going to highlight the triangle. Okay, and let's draw that triangle in a very much more simple form. So here we go. Remember, this is straight across horizontally. This is perfectly vertical, so that means this is 90 degrees. This is 40 meters, right? 40 meters. This is 188 meters. And we are trying to solve for this angle here. So I'm going to represent this as treasure, boat, okay? And we can just represent this as anything here. I'm going to represent it as Q, okay? Now again, we are trying to solve for this angle, so this is angle T. So my question is angle T. So we have taken quite a confusing sentence and represented it in a very simple triangle, which is very useful to us. Okay, so we're trying to solve angle T. Now remember, ask yourself, how does angle T relate to the things that I know? Well, if I'm looking here, first off, where is my hypotenuse found? My hypotenuse is across from my 90-degree angle. Okay, so there's my hypotenuse. And looking at the values that I know, I have angle T. Opposite to that is 40 meters, and this would have to be the adjacent side length. So I'm given opposite and adjacent. Now, what relates those two things with an angle? Well, that would be TOA. Tan angle equals opposite over adjacent. Okay, and right now you might be like, obviously, but again, we are going to be introduced to sine and cos. Okay, now here we can plug it in terms of angle T. So for angle T, what's the opposite side length? Well, that would be across from it, so 40 meters, or B to Q. So I'm going to represent it as BQ. What's the adjacent? Well, the adjacent here would be 188 meters. So that would be Q to T. So Q to T. And now we can plug in all the values you have. Remember, we're trying to solve for Q2. Angle T. Okay, so tan angle T equals, well, what's BQ? BQ is 40 meters. What's QT? It's 188 meters. Okay, and now remember, we're solving for angle T. How do I solve for an angle? I must use the inverse of tan. So 40 over 188. I'm actually going to plug in the tan ratio into inverse tan, which is going to give me the angle. Okay, so that will give me, remember, you should practice plugging this in your calculator. If we plug this into our calculator, remember, now we have to use inverse tan. So tan is found in the, whoa, sorry about that. Accidentally pressed the wrong button there. The inverse tan, okay, is found in the yellow above the tan. So we have to press second tan, or the yellow button, then wherever your tan negative's found, 40 divided by 180, and make sure you're in degree mode. If you're getting a different number and you know you're doing it right, you're in the wrong mode, okay? And that's gonna give us 12 degrees. So he has to angle himself for an elevation of 12 degrees from the horizontal. Okay. So remember, if that if you maybe got lost somewhere, you can obviously just rewind, rewatch the video. If things are really not making sense, take down all your notes, come in and ask questions. Okay. Now, if he properly orientates himself towards the boat, aka he does in fact show himself to be aiming 12 degrees, how far must he swim? So we're dealing with the same triangle here, but now we just want to know how far would he have to swim here if he actually in fact angled himself properly. Well, remember, we know quite a bit about this triangle now. This is 188. This is 40 meters. I'm going to use the same BQT. We want to know, if he did in fact angle himself 12 degrees, how far would he just need to swim from T to B? So my question mark is, how long is T to B? Now here, ask yourself, what am I given and how does that relate to the thing I'm trying to find? Well, I have two side lengths and I'm trying to find my hypotenuse. Okay, so I'm going to use Pythagoras. A squared plus B squared equals C squared. Now remember, the first thing you always want to do is, what is C? What is your hypotenuse? Because that's the thing that can't change. C is what we're looking for. So in this case, your hypotenuse will be B to T. So B to T squared. And now remember, the legs are kind of interchangeable. You can make A 188 or you can make A 40. I'm just going to make it 40. So 40 squared plus B, which is 188 squared. So let's plug these into our calculator. So 40 squared, remember your square button is found right there, okay? 40 squared gives me 1600 plus 188 squared gives me 35,344. And here we can add those two together. So 1600 plus 35,344. So that gives me 36,944. And that's BT squared. And then we still need to solve for BT because it is being squared. So I'm going to square root both sides. So remember, how do I get to square root? Well, if you look down here on your calculator, right above the x squared is a yellow square root. We need to get the yellow, so we have to press our yellow button and press x squared, which is giving me the square root, and we can plug this in, 36,944, and that's going to give me a length for BT of 192, and we're just going to round it to the nearest meter here. Okay, so that would be meters. So if he directs himself properly, he just has to swim 192 meters back to the boat. Okay, now remember, Word problems can be difficult. Look at how much information we got just by drawing simple pictures and noting down things we need. Okay, it takes practice. You need to practice organizing your work properly in order to do very well. Other than that, if things didn't make sense, remember to take down the notes, try and maybe rewatch the video or just the section that didn't make sense. But again, always come in and ask questions. I love when you guys come in and ask questions. So check your understanding if you're feeling good for this section. So AFL 2.2.